Hi students, in previous lecture we discussed about the calculating the powers of an iota. So in this lecture we will discuss some performing some mathematical or algebraic operations on complex numbers. So before going to discuss about the mathematical operations on complex numbers, we need to consider. So now here I am representing this small circle with real numbers and this big circle with complex numbers and what it tells us. So let I am considering a complex number z equals to x plus I y. Then if in this one, if y equals to 0, then what happens to this complex number? Z will become x, where we know that x is a real number. Okay, x is a real number. So if x is equals to 0, if the real part is 0, okay, if the real part of a complex number is 0, then what will get? Z equals to iota times of y. So now this iota times of y is called as imaginary, number, So from this one we can say it as, if y equals to 0, z equals to x, which is nothing but a real number. Okay, so all the real numbers, x is a complex number now. So all the real numbers are complex numbers. But if x is equals to 0, we are getting z is equals to iota times of y, which is as imaginary. So that means from this one we can conclude that all the real numbers, otherwise every real number is complex number. Every real number is complex number, but now z is equals to iy is a complex number, but it is not a real number. So that means, but all the complex numbers are not real. Okay, so this is the important one. So every real number is a complex number, but all the complex numbers are not to be real. Okay, so this is the important one. So from this one, so a complex number x plus iy is said to be real. A complex number x plus iy is said to be real if the imaginary part is 0. If the imaginary part is 0. Okay, so and a complex number, now this type of numbers, if the imaginary part is 0, a complex number is real number, these type of numbers are called as purely real. Then the complex number is called as a purely real number. Okay, if the real part of a complex number is 0, if real part of complex number is 0, so real part is 0, that means what it is here, x is equals to 0. If x is equals to 0, then the complex number is iota times of y, now which is called as purely imaginary. Okay, so now a complex number is said to be a purely real number when, okay, complex number is said to be a purely real number when its imaginary part is 0, and a complex number said to be a purely imaginary number if its real part is 0. Okay, so now moving forward, Now I am considering complex number z1 as a plus iota times of b, and complex number z2 as c plus id. Okay, now we are having two complex number. Then we will perform the addition of these two complex numbers. Okay, so that means we need to write it as a plus ib plus c plus id. Okay, so which is like a regular real number addition. So 3 plus 2 we will get it as 5. Okay, so regular real number addition. So for this one, if we go on adding this, we will get it as a plus c, and if I take I as a common, then I can write this is as b plus d. Okay, so z1 plus z2 can be written as a plus c and iota times of b plus d. So that means when the two complex numbers are added, simply the resultant is adding by, will get by adding the real parts of the two complex numbers and by adding the imaginary parts of the two complex numbers. For example, I am considering z1 equals to 3 plus 4 times of I, and z2 equals to minus 1 plus 3i. So to get the resultant of z1 plus z2, simply add the real parts. What are the real parts? 3 and minus 1. So we will get it as 2. And add the imaginary parts. Okay, 4i plus 3i, 7i. So which is the result? Okay, so the same thing can be represented in the ordered pair form. So how we represented in the ordered pair form? Z1 equals to ordered pair form a comma b, and z2 equals to c comma d. Then we can write it is as z1 plus z2 equals to a plus c comma b plus d. So in the addition of two complex numbers, we need to remember the point as add real parts, add real and add imaginary parts. Add real and add imaginary parts, we will get the required results. Then moving to the subtraction of the two complex numbers. Okay, moving to the subtraction of the two complex numbers. So now I am considering z1 equals to again as a plus ib, z2 equals to c plus id. Okay, so now we need to perform z1 minus z2, which is equals to a plus ib minus c plus id. Just perform the regular real number subtraction. Then what we will get? A plus ib minus c minus id. So separate the real and imaginary parts. Then we'll get a minus c plus iota times of b minus d. Okay, a minus c plus iota times of b minus d. Okay, so which is the subtraction of two complex numbers. Okay, subtraction of two complex numbers. And here consider z1 equals to, then what we are getting? Let's consider 3 plus 4i, z2 equals to minus 1 plus 3i. Then what is the resultant of z1 minus z2? Just simply subtract the two real parts. 3 minus of minus 1, we will get it as 4, and subtract b minus d. So that means 4i minus 3i, then we will get it as I itself. I into 1, that as I itself. So which is the subtraction of the two complex numbers, and which can be represented in the point form as z1 equals to ordered pair form a comma b, z2 equals to C comma D. Then we can write it as Z1 minus Z2 equals to A minus C comma B minus D, which is the resultant of the subtraction of the two complex numbers. And here we need to consider one more important thing. So Z1 plus Z2, so whatever we performed Z1 plus Z2, we obtained it as A plus C plus iota times of B plus D, and whereas Z1 minus Z2, we obtained it as A minus C plus iota times of B minus D. Okay, so now I will perform Z2 plus Z1. What I will get? Z2 is C plus ID plus Z1 is A plus IB, and I will get it as C plus A plus iota times of D plus B, and which also can be written as what it is, A plus C plus iota times of B plus D. Okay, from this one, so we can conclude that Z1 plus Z2 is equals to Z2 plus Z1. Okay, Z2 plus Z1. And coming to over here, let's we explain with the help of the above example. So we obtained Z1 minus Z2 as 4 plus 3i, and if what is the result of Z2 minus Z1? Okay, Z2 minus Z1, so that means minus 1 plus 3i minus of 3 plus 4i. So then what will get over here? Minus 1 plus 3i minus 3 minus 4i. Then the resultant is, we are getting it as minus 1 minus 3, add the real parts, minus 1 minus 3 minus 4 minus I, so which is equals to Z2 minus Z1. But here we will get Z1 minus Z2 as 4 plus I, but Z2 minus Z1 is minus 4 minus I. So from this one we can conclude as Z1 minus Z2 not equals to Z2 minus Z1, but Z1 plus Z2 equals to Z2 plus Z1. Okay, so these are the subtraction and addition of operations on complex numbers. Okay, in the next lesson we will discuss how to find out the multiplication and division on the complex number, how to find out the multiplication and division on complex numbers. So before that, before ending this lecture, now we find it the iota powers. Iota power n is finded, but if the question is what is iota power minus 1, how to find out these type of questions? So the iota power minus 1, simply write it as 1 by iota, 1 by I, and now rationalize this, I by I. Then what we'll get over here? I by I square. So I by I square value, we know that, which is as minus 1, which is equals to minus I. Okay, so now we can write it as I power minus 1 equals to minus I. Simply by writing it as I power minus 1 as 1 by I and rationalize, you will get the required result. Okay, if it is I power minus 3, then what I will get? I can write this as I power 3, 1 by I power I cube. Okay, 1 by I cube into, I am making it as I by I. Then what I will get? I will require result I by I power 4. We know that I power 4 is 1. Simply we will get it as iota. So I power minus 3 equals to iota. So this is the way of finding iota power negative powers. Iota of negative powers. Okay. Now I am giving assignment to you. Okay, so now these are the three questions given as assignment to you. Solve these questions and post your answers in group. So what it is, find the value of iota power minus 127. Then the next question is find the value of summation n is equals to 1 to 13 I power n plus I power n plus 1. Then third question is find the value of 1 plus I square plus I power 4 plus I power 6 plus I power 8 plus so on I power 100. Okay, try to solve these questions and post your answers in group. Okay, thank you. In the next lesson we will discuss multiplication and division of complex numbers. Thank you, students.